Welcome to another exciting lesson of integrated science with Daro teaching. I'll be your instructor, Felicitas. In our previous lesson, we learned about the atomic structure. In today's lesson, we are going to learn about the atomic number and the mass numbers. Grab your notebook and your pen because we are about to dive into the world of atoms. In our last lesson, we learned that atoms, despite them being very small, they are the most important particles because they do take part in a chemical reaction. Everything you see around us, including me and you, are made up of atoms. Let's quickly remind ourselves. Atoms have two regions: the nucleus, which is at the center, and the energy levels that surround the nucleus. Inside the nucleus, we found the neutrons and the protons. And on the energy levels, we found the electrons. Do you remember what we call protons, neutrons, and electrons together? Yes, you are right. We call them subatomic particles. The subatomic particles will help us to find the atomic number and the mass number of each element. And that's what this lesson is all about. Let's start with the atomic number. The atomic number is the number of protons in the nucleus of an atom. When you see the atomic number of an atom, you know how many protons there will be in that atom. Every element has its own unique atomic number. Just like our fingerprints, no two elements have the same number of protons. For example, hydrogen has one proton. Therefore, hydrogen is atomic number 1. On the other hand, carbon has 6 protons, and therefore we can say carbon is atomic number 6. Now on to the mass number. Do you remember we said that protons and neutrons are together in the nucleus? Yes. The mass number is the sum total of protons and neutrons in the nucleus of an atom. Let's take argon as an example. Argon has 18 protons and 22 neutrons. What's its mass number? Yes, 18 plus 22 equals 40. Therefore, it means argon has a mass number of 40. Easy, right? Here's something interesting. Some elements have atoms with different number of neutrons. This kind of atoms, we call them isotopes. For example, some atoms of hydrogen have 1 neutron, others 2, and others do not have a neutron at all. Therefore, we say that hydrogen has 3 isotopes. They are like siblings, same element but different mass numbers. Let's get into this activity together. Do you see this table behind me? Let's try filling in part of this table together. We'll do a couple and then you try the rest on your own. Let's look at hydrogen. The number of protons is 1 and the number of neutrons is 0. Therefore, the mass number is equal to 1. Let's do one more. The mass number for beryllium is 9. And the number of neutrons is 5. Therefore, the number of protons is equal to 4, which is the difference between 9 and 5, and the symbol for beryllium is Be. Pause the video and give the rest of the table a try. Well done on completing the table. I know you did your best. Now let's go through this together. Let's look at the third column total number of protons. Can you see that it runs from 1 to 10? It is good to know this, since this also makes it easier for us to figure out which number comes next. We have filled in the second column where you can see the symbol for each element. As you can see, hydrogen symbol is H, while helium symbol is He. Since the mass number of helium is higher than hydrogen's mass number, hydrogen will come before helium. It is easy to remember helium symbol because it is the first two letters of helium, whereas hydrogen is the first element and we simply use H as its symbol. Now, if you have the order of the elements and you know two of the numbers, either the number of protons and neutrons or the number of neutrons and the mass number, you can work out the missing number. For helium, we know that we need to add the number of protons and number of neutrons together to find the mass number. If the mass number is 4 and the number of neutrons is 2, we need to calculate the difference between those to find the number of protons. This is equal to 2 and helium is second on this list. So we know this works out perfectly. You can use this method to work out all the others. Number of neutrons for lithium is 7 minus 3, which is equal to 4. Number of neutrons for boron is 11 minus 5, which equals to 6. Number of protons for carbon is 12 minus 6, which equals to 6. Number of protons for nitrogen is 14 minus 7, which equals 7. Mass number for oxygen is 8 plus 8 gives us 16. Mass number for fluorine is 9 plus 10, which is 19. Number of neutrons for neon is 20 minus 10, equaling 10. Well done! Let's now look at how we can write this information quickly and neatly. We use something called atomic representation. You write the mass number at the top left and the atomic number at the bottom left, next to the atomic or chemical symbol. Here is an example. This helps scientists to know how many protons and neutrons an atom has. So grade 9, to wrap it up, atomic number is the number of protons present in the nucleus of an atom. Mass number is the sum total of protons and neutrons in the nucleus of an atom. Also, it's good to know that some atoms of the same element have different number of neutrons, and these ones we call them isotopes. That brings us to the end of today's lesson. You've done a fantastic job. Next time, we'll take a closer look at electron arrangement in elements. Make sure you do not miss it. Be sure to check your understanding of this lesson by clicking the self-marking assessment link below. If you enjoyed this lesson, kindly make sure to like and subscribe our channel. And don't forget to share it to your friends. Bye. See you next time.